Hey everyone, and welcome back to Newegg TV. My name is Paul. Today I'm going to be doing an unboxing, well, perhaps not an unboxing, but maybe more of an unbagging, but an overview as well as some benchmarks on this new line of hard drives from WD. This is the WD Black series of desktop hard drives, and they're new, not like the old WD Black hard drives. Now, if you're not familiar with WD's hard drive nomenclature, the various types of hard drives that they have, these are consumer drives, so they're designed for use in desktop situations. Western Digital identifies their drives with colors, and the Black series of drives is the highest end when it comes to the consumer range. They also have blue drives, they have red drives, they have green drives. Each of those is kind of suited for different purposes, but the Black series is made for high-end gaming, workstations, and media center applications. The new Black series has some updated design and features. They're touting a 26 to 48% performance increase over the competition when you're talking about drives in the same range. And they have improved the processor. They've gone with a dual-core processor inside. They've also made some changes to the firmware and controller to improve the performance. Another thing that you're going to get with these drives, although you can't see it right here, is you will also get WD Acronis True Image software. And that is cloning and data migration software that you can download directly from the WD site. Just go to wd.com and or you can search for the Acronis True Image and you can download that. So if you are going to be migrating data from an existing system, or if you want to clone a drive with an operating system, that makes it really easy to do that. I'm going to go ahead and take at least one of these out of the bag. I've been benchmarking the 2 terabyte and 4 terabyte versions over there, so I will be sharing some of those numbers with you in just a moment. But as these are OEM drives, or original equipment manufacturer, basically you're not going to get a retail box. You're just going to get the drive itself, which, let's be honest, is all most of us really need. If you are going to be plugging this in, bear in mind you will need to route a serial ATA power cable over from your power supply and your desktop computer, as well as a serial ATA data cable that's not included. These are SATA Revision 3 6 gigabit per second compliant, so they do operate on that interface. Although honestly, if you're plugging this into a SATA Rev 2 3 gigabits per second interface, you probably aren't going to see much performance degradation there. They also have a 64 megabyte cache, and every single one of these drives comes with a 5-year warranty from WD. As far as the platters inside, most of these are going to be using 800 gig platters, so the 3 terabyte one here, for example, uses 800s divided by 3 terabytes. The 4 terabyte version uses 5 800 gigabyte platters. That one I'm pretty sure of myself. I guess that means the 3 terabyte is going to use 4 800 gig platters. Okay. Moving right along, the 1 terabyte model, which is also right here, although I have not unbagged that yet, is the only one that uses a 1 terabyte platter. So this one just has a single platter in there, and that's the main difference when it comes to the drives in these lineups. Next up, why don't we go ahead and take a look at some slides, because there are some features of these drives that are a little bit difficult to show you. Just to go over what we're going to talk about, it's HRC, so these are some of the new technologies they've done. HRC is a high resolution controller, which they've done for increased data precision and accuracy. They have VCT technology, or vibration control technology, for reliability, CPT, or corruption protection technology, also improved caching algorithms, optimized read and writes, and they've gone with 4K formatting with these for the first time. That's versus 512K, which Western Digital is saying is giving an 8 times better performance, which is pretty cool, or at least when you strictly compare 4K versus 512K. So why don't we go ahead and take a look at some slides. So first off, here's a look at VCT, or vibration control technology. Basically, it's able to adjust itself and adapt to mounting problems, such as not being properly placed in the sled, or vibrations that occur in the chassis, increasing performance, reliability, and data accuracy. Next up, we have what is known as HRC, which is high resolution controller technology. So the controller they're using, as mentioned, is a dual core this time around. Improved architectural design increases performance, and it matters because high resolution controller technology doubles the bits within the controller and increases drive calculations to improve tracking precision, resulting in more accurate read-write functions, overall increasing performance once again. Next up, we have CPT, that's corruption protection technology, and basically this is going to monitor your power levels within the system and limits the potential problem of data corruption during an event loss of power, which increases hard drive reliability overall once again. Finally, we have Stable Track, which I didn't mention earlier, but if you haven't looked at the inside of a mechanical hard drive, you have a bunch of spinning platters, and keeping them stable is often very, very important. So the stable track technology reduces vibration influences by securing the motor shaft inside. It stabilizes the platters. It increases system performance, and bear in mind this is in the 4 terabyte, 3 terabyte, and 2 terabyte models. And basically it protects data by securing the motor shaft at both ends to reduce vibrations and increase tracking accuracy during read and write operations. Once again, increasing performance. I'm going to run over some benchmarks next. I did benchmark 2 of these drives, so I'm going to be sharing 4 terabyte and 2 terabyte numbers. WD also sent over one of their previous generation drives, which really isn't all that old, but just to give you guys kind of an idea of the performance improvements and how they're going to bear out in some of the actual benchmark numbers, I will also be showing this one here. I also said I was going to show you guys how to tell the difference between the older black drives and the newest black drives, and it might be kind of difficult, but here's the two terabyte versions side by side, and if you can just by looking tell the difference, well, I guess this one has black stickers on it versus the new one, which is using silver. That's one difference. The model numbers are different, so that's probably the best way, of course. The older drives were WD2, which is the capacity, so it was 2002 FAEX. The newer ones are WD, and then it will be a 1, a 2, a 3, or a 4, depending on the capacity, but 2003 FZEX. So there's a 3 instead of a 2, and a Z instead of an A. So there's kind of your visual difference between the two. And now for some benchmarks. I'm just going to be showing you guys some screen caps that I did as I was benchmarking, so I apologize if the text is kind of small in areas. But we're going to start off with Atto, which is a very popular benchmarking utility for both hard drives as well as solid-state drives. We're starting off with the old drive. So this is the the last generation black drive, the 2 terabyte. So each set of slides I show you will do the 2 terabyte old gen, the new 2 terabyte, and then the new 4 terabyte, since those are the 3 tests that I ran. But you can see all of the results right here. Basically, it tests a bunch of different transfer sizes, and as it moves up the scale, you will see it gets more towards its peak performance, which happens to be about 146 megabytes per second on the writes, and was able to get to about 160 megabytes per second on the reads. Next up is the 2 terabyte new drive, and those results are down there. If the scale looks smaller, that's because this drive was actually able to go beyond 200 megabytes per second, which means it had to extend this scale to 500. So these lines here are actually longer than you might expect them to if you're looking at the old chart. But this was able to hit some really nice results, actually. 192 megabytes per second on the writes was the fastest it got there, although the average would be a bit below that. And again, it did pass 200 megabytes per second on the reads, which is fantastic, fantastic performance for a mechanical drive, and really performance that I haven't seen in a mechanical drive apart from some of the enterprise drives, for instance, that Western Digital comes out with, which are fantastic drives. So it's great to see that the black drives are now achieving a lot of that same performance. Here's the 4 terabyte drive. Not quite as good a performance as a 2 terabyte drive, but of course the trade-off there is that you get much more capacity. But again, still an improvement even over the 2 terabyte drive from last generation. We hit about 170 megabytes per second max on the writes, and we hit about 177 was about the peak, just shy of 180 on the reads. So again, very excellent performance. Next up, we have Blackmagic Disk Speed Test. This is a utility from Blackmagic. It will test your drive, and it will give you some feedback on whether Blackmagic feels that it is a adequate drive for use when you're working with different video footage. So as you can see here on the writes and the reads, and we're going back to the last gen 2 terabyte drive here, we had about 140 megabytes per second both ways, and we can see some check marks down here for PAL and NTSC and the different types of video formats, compression levels, as well as quality, so you can see what is currently being recommended there. Jumping to the new 2 terabyte drive, we hit some nice improvements here, about 30 to 35 megabytes per second more, 174.5 on the writes, 173.3 on the reads. We had a few more check marks that lit up. Working with video can be quite difficult, and often if you are working with video on mechanical drives, this will be a great situation where a RAID configuration would be awesome. So actually strapping several of these drives together will give you some increased performance, but again, still very nice performance overall. And then third, we have the 4 terabyte new black drive, and again, slightly less than the new 2 terabyte, but definitely more than the old 2 terabyte, 158.9 and 157.7 were our results there. And next up we have the old standby. This is Crystal Disk Mark, and I apologize, my formatting is going to be a little bit different from one test to the next here. But going back to the old 2 terabyte drive again, 151 and 147 respectively, we can see the full list down here as well as input-output operations per second, which were in the 300 to 400 range. Going to the new 2 terabyte drive, and sorry I reorganized these because I actually switched monitors and I couldn't fit it all in. Anyway, so this is a new 2 terabyte drive, 184.5 and 178.8 on the sequential reads and writes. Excellent, excellent performance once again. There's your IOPS over there on the left as well if you wanted to check those out and give a comparison. Here is the new 4 terabyte black drive. And again, 167 and 163, less than the new 2 terabyte, more than the old 2 terabyte. So we're seeing the same type of performance numbers from what we saw before. Lastly, we have PC Mark 7, and I apologize, the results here are all text-based, and it's very small, but it's down there in the lower left-hand corner. I'm just going to reference the overall score. So this was the secondary storage test, which was run strictly on the drives. They were not being used as an operating system. They were just being used as an add-on storage drive. Secondary storage score for the old 2 terabyte was 2,356. Raw secondary storage score was 734, and you can see all the individual numbers for the tests right there. This was the only test where I actually saw a bit of a difference from the earlier tests in that the old 2 terabyte drive actually still performed quite admirably on this. So the old 2 terabyte drive actually had the best secondary storage score here when it comes to the overall, but the raw secondary storage score we saw an improvement. So this is the new 2 terabyte, which hit a 2,316 on the secondary storage. Whoops, sorry. Secondary storage right there, and then 754 on the raw secondary storage score. And then lastly, we have the 4 terabyte new drive, which hit 2,264 and 717 respectively on both of those tests. And the last thing I didn't mention for these benchmarks was what I was testing on. I should have said that at the beginning, but we're using an Intel Core i7-3570K CPU. It's on a Z77 chipset motherboard, and we were connecting to the native Z77 serial ATA controller, so we're using the native SATA 6 gigabits per second connection. And if you don't want to take my word for it, go ahead and check out storagereview.com. They do lots of reviews, they know lots about storage, and they gave the 4 terabyte version of this drive a Editor's Choice Award. And that is going to wrap it up for this video, guys. Once again, we've been taking a closer look at the new WD series of black mechanical desktop hard drives. I'm Paul with Newegg TV, and if you enjoyed this video, don't forget to subscribe to our Newegg TV YouTube channel, leave me some feedback down in the comments section, or maybe even click the like button if you enjoyed this video. Thanks for watching, and we'll see you next time.